Hello and welcome to IIT Gyan. This is Tapan, and today in this session we are going to study some of the commonly used sensors. So this will be our agenda for today. We have used three types of sensors in our smart home gateway. First one is the passive infrared sensor, second one is the ultrasonic sensors, and third one is the magnetic rate switch. So for each of them, we'll come to know their working principle, how to integrate that particular sensor with our microcontroller, and how to program that sensor with ESP8266, that is Node MCU. So let's start. So what is the working principle of a passive infrared sensor? So it is an extremely useful device for detecting the presence of a moving body. So whether it is a human or it is animal, so any living body, it emits infrared energy associated with it. So I have given here the image of a PIR sensor. It is having three pin. First one is the VCC. It may work on 3 to 5 volts. Second is the ground, and middle pin is the data pin. Here 3-volt regulator, it is inbuilt on this chip, and it is covered with a plastic convex cover which is fixed on it. So this is the principle of working. Whenever any animal or human, it comes in its range, then it is able to detect this, because as I already said that any living body emits IR radiation. So its detector sees a sharp increase in the infrared energy when any of the intruder comes in its range. Next step is how to integrate PIR with Node MCU. So if you want to run a PIR sensor, you must need a separate 5-volt supply. So right now, as a last option, I have connected it with V-in, which is having 5-volt, but it is not recommended. Please use an additional and separate power supply for PIR sensor. Only the middle pin or the data pin of PIR sensor, it should be connected to the D8 pin of your Node MCU ESP8266. And after connecting it, you have to mount it in the correct position, because a plastic convex cover, it is fixed on it. So you have to expose its surface to the intrusion detection part. So this is all like how to integrate PIR with Node MCU. Here I am showing you how to program PIR sensor with the Node MCU. So since I have connected the middle pin or the data pin of my PIR sensor to the D8 pin of my Node MCU, so either it will be giving 1 or 0, since it is a digital sensor. So I have to declare here data type as an integer. In the void setup, I have to declare the PIR underscore output as an input, because the output of PIR I am giving to the input of my Node MCU. So it is in input configuration, and this is for beginning my serial communication between PIR and Node MCU. In my void loop, what I am doing here, I have pre-declared PIR underscore value as an integer, because whatever the status of the PIR underscore output will be there, that will be digitally read by, and it will be stored in this data type. I have introduced here 2000 milliseconds delay, so within 2 seconds it will detect presence. So if PIR underscore value, if it is 1, it is 1 means somebody is there, so I am printing motion is detected, and in the else case I am printing that no motion is detected. So it will be seen on serial monitor. The second sensor I am using in my project is the ultrasonic sensor. So it is coming under the category of active sensor. So in every active sensor, it emits out the radiation and it waits for the reflection to come back. So whenever any object is coming in its path, the ultrasonic waves, it gets reflected back and it is received by this receiver pin. So this ultrasonic sensor, it is having two openings in its front. One opening is for transmitting the ultrasonic waves, it is just like tiny speaker, and other, this one pin, it is for receiving it. And we will connect this ultrasonic sensor to our Node MCU. It is an indirect method for measuring the distance of an object from the source. Since we know that the speed of sound is approximately 341 meters per second, so depending upon the time interval which it takes to come back, so use this mathematical equation. Why we are dividing here by 2? Because the sound wave, it has to go to the object and it has to come to back. So that is the reason we are dividing it by 2. Next step is how to integrate the ultrasonic sensor with the Node MCU. So you must need a separate 5 volt supply if you want to run the ultrasonic sensor. So it is having total 4 pins. The VCC pin has to be connected to 5 volt supply. The ground pin has to be connected to ground, and the remaining 2 pins like trigger and echo. So trigger has to be connected to D4 pin as per to our circuit diagram, and this echo pin has to be connected to the D5 pin of my Node MCU. And always remember that ultrasonic sensor, it runs only on 5 volt. Now how to program Node MCU for ultrasonic sensor. So trigger pin of my ultrasonic sensor I have connected to the D4 pin of my Node MCU, and the echo pin of my ultrasonic I have connected to the D5 of my Node MCU. So in my void setup I have configured the trigger pin as an output, because from here pin number 4 I am emitting the ultrasonic waves, so I have declared it as an output, and at D5 I am getting the echo or the reflected radiation, so I am declaring it as an input to my Node MCU. In my void loop, first what I am doing, I am making the trigger pin low, then again I am making it high, and again I am making it low. So for a particular interval of time my trigger pin is high, and for that particular interval of time only I'll be getting echo as high. So this is my inbuilt function which is measuring the time for which the echo pin is getting high signal. So I am storing this in a variable called duration, and the duration means the time multiplied by this speed of sound divided by 2. So by this formula I am getting the information that how far an object is from this ultrasonic source. The last sensor I have used in my project is the magnetic reed switch. So a reed switch has two leads made up of ferromagnetic material. Here in this image you can see this is the first lead and this is the second lead, and initially they are separate from each other, and as soon as you bring a magnet near to it, they come closer and make a flat contact so that a current can flow through it. So this is the principle of working of magnetic reed switch. So it comes in two category. First one is the normally open reed switch, and second is the normally closed reed switch. In our project we have used normally open reed switch. So here you can see the same principle. Initially they were separate, and as soon as you are bringing magnet to it, they come closer and make a contact. So this is all about the theory of reed switch. The next step is how to integrate the reed switch with your Node MCU. So here you are having two options. You can connect the D6 pin of your Node MCU to the reed switch and another end of reed switch to the ground. So here you can use the internal pull-up resistor of your Node MCU to make it high. And the second option is that if you are using a separate power supply, so the same power supply you can connect an external resistor and you can give it to the D6 and D7 pin of your Node MCU in such a way that whenever they are in open condition, this VCC will go to the D6 and D7 pin, and by bringing the magnet, as soon as they become closed, that VCC via this resistor will flow to the ground, and this completes your circuit. The last step is how to program the Node MCU for reed switches. So since I have connected two reed switches at D6 and D7 pin of my Node MCU, so I just want to read the status of D6 and D7 pin. Here, as per to the first case, I am making the use of internal pull-up resistor. So this is the command to use the internal pull-up resistor and make D6 as high. So I am collecting the status of D6 pin in a variable called proximity 6. So whenever I am bringing magnet near to my reed switch, so the current will flow through it and it will go to the ground, and I'll be getting a low signal on my D6 pin. So this I am connecting in my proximity 6 variable, and when I'll keep my magnet away from the reed switch, so that contact will move away and the switch will be opened. So I am printing this message on my serial monitor. As a last part of this tutorial, I am showing you the complete circuit diagram. I have used three sensors. First one is the ultrasonic, second one is the PIR, and third one is the reed switches. So in order to perform some action, I have connected here three LEDs at the D1 pin, D2 pin and D3 pin of my Node MCU. So they are in real sense representing pump, fan and lights. And I have connected three resistors in series with them and tied them all together and connected it to the ground. So what exactly I will be doing from my IBM Watson platform, I'll be sending the commands back to this Node MCU, and this Node MCU is going to turn on or off these LEDs. In real scenario, they will be controlling the lights, pumps and fans of my home. The next objective of this project is the monitoring part. So since I have connected this ultrasonic sensor in garage of my home and I just want to see whether car is parked or not, so the same status will be updated in the IBM Watson platform where I'll be seeing it in some web UI. Second is the PIR sensor, which I have connected in my home just to see whether if any unauthorized person is there or not. So it will be detecting the human presence there and it will be updating the same status in the web UI. Third is the read switch. So I have connected two read switches into different doors, so as soon as any person is opening the door, so the same status will be updated here in my web UI. So I'll get an information that my door has been opened by someone. So this is the monitoring part. So in this way we are going to achieve complete home automation by using the Node MCU. Thank you.